Hello, and welcome to MVAO201 Advanced Auto Operator Facilities. This is Part 1. MVAO201 is the fourth in an 8-part series of courses covering Auto Operator. In this session, we'll be discussing the use of variables in Auto Operator. First, let's identify what a variable is. According to the dictionary, a variable is a quantity that may have different values, and this is a symbol for such a quantity. And you go, what does that really mean? Well, a variable is a container for holding data. In Auto Operator, variables can hold many different types of data, including numeric, character, and hexadecimal data. It really doesn't matter to Auto Operator. What we're concerned with is that we have a name of a variable that contains some value. When you reference variables in Auto Operator, you prefix the variable name with an ampersand. So the variable IMF text would be referenced as ampersand IMF text. And this variable happens to contain the text of a message that caused an event. The data that's associated with a variable is called the value. So in this case, we have a variable ampersand IMF day. We're setting equal to mon, so the value of IMF day is mon. If you do not initialize or set a variable to some value, Auto Operator will represent it as a null. Auto Operator populates many variables when events occur in the system. You can see the Auto Operator documentation for a complete list or refer to the online panel help. Here are some examples. There's one called IMF text that contains the message text for an event that fires the rule. There are variables that start with word followed by some number that are the parsing of the words out of the message that caused the event. IMFO job is the name of the started task or job that caused the event to occur. IMF reply is the WTO number that may be associated with the message. IMF origin gives the name of who generated the message, either a job name or a subsystem ID, and so on and so forth. Auto Operator variable names are limited to 32 characters, and the values can be up to 256 characters long. It's also possible to define long variables in Auto Operator, although those have special considerations for handling. Now that we have a common understanding of what variables are, let's look at the different types of variables that Auto Operator supplies. First type of variable are event variables, and these are the variables that are associated with an event coming into the rules processor. As such, their event variables are only available to the rules processor. If you want to share them with an exec, you can invoke the exec and pass the variables on the parm. We also have TSO variables, which are your typical TSO variables for execs, and they apply only to your execs. We also have local variables, which can be used by execs within the same thread that pass information. The most common type of variable that you will see are shared variables, and these can be accessed by both rules and execs. These variables are maintained across the BBISS warm starts, and you can set them at initialization time in the UBBParm BBIVAR member. Another type of variable are the profile variables, and these are available only to execs, and they are written to disk, so they're maintained across the restarts of the BBISS as well as IPLs. The last type of variable are sysplex variables, and these are also available to rules and execs. And sysplex variables are a type of shared variable, but they have a special prefix name, and we'll talk about that later. There are also two categories of variables in Auto Operator. We have simple variables, which are essentially names of variables that begin with an ampersand, and it gets substituted with whatever that value is, a fairly simple variable. We also have compound variables, which start with an ampersand and then are immediately followed by an exclamation point. And when Auto Operator sees that, he will leave the stem alone, which is the section between the exclamation point and the period, and then he'll perform substitutions on any of the later values. And we'll talk about that in a minute. Let's look at an example of how a compound variable is resolved. So if we look at the top here are the settings for our variables. We have ABC set to first, my name is equal to second, and ABC.second equal to third. So if I look at a variable ampersand exclamation point ABC.myName, the way this is going to be processed is the first pass through, the auto operator is going to see, oh, I've got an ampersand exclamation point, so I'm going to leave everything alone to the dot. So he's not going to substitute the ABC. And then following the dot, we have my name. Well, we had my name set to second if we look at the top of this slide, so he's going to substitute second in there. And then on the next pass through, this time he's going to resolve the ABC stem dot second, which is what my name was. So ABC dot second is equal to third. So at the end of the day, the ampersand exclamation point ABC.myName is equal to third. Event variables are variables that are automatically populated when an event occurs in the system and AutoOPERATOR processes it. There are many such variables. I will show you those in a slide or two. But essentially, the event variables come with the events coming into the rules processor, and you get a unique set of event variables for each event. These event variables can be passed to an exec if you call it from the rule. Now, here's an example of an event. We have a message IEF 403I space job space test job space started. And some of the variables that would be set from this are IMFO job would be set to test job because that's who the origin of the message was. IMF day happens to be Tuesday, but you can't really tell that in the message. So you just trust me that this happened on Tuesday. Word 2 is job, and you can see that's the second word separated by blanks. And then the IMF MS type, the message type is N. If you want to find out which event variables are available, you can use the rvar command in AutoOPERATOR. And here we'll see the list of the variables that are available for the events. This is only a partial list. If you continue down, there will be many, many more of these event variables available. The most common variables you'll work with are probably going to be shared variables. There's one shared variable pool per BBISS, which is typically one per auto operator. Rules can access shared variables, and you can also have execs accessing shared variables. You can display the contents of variables in the AO journal by using the .d space v command. If you wish to limit the display to variables that only match a certain prefix, you can pass that as a parameter to the .d space v command. Important to note that you should not create variables that start with the letter Q. BMC reserves those. We populate many of them. Examples are ampersand QSMF ID gives the SMF ID of the system. QIMF ID gives the subsystem ID of the BBISS. It is important to consider having a naming convention that makes sense to you. That makes it a little easier to keep track of your variables. And here's an example of the .d space v command, and in this case we passed an argument of q asterisk. And you can see immediately following that AutoOPERATOR returns the list of variables as well as their settings. In the classic AutoOPERATOR's interface, you can type in var on the command line, and you'll also get a list of the variables in their settings, as well as an indication of which pool they're in. Similarly, we can display the var command in the Windows mode, and we'll see a display with the same data presented a little differently. As I mentioned earlier, we can use variables in rules. These are limited to event variables and shared variables. If you happen to have a variable with the same name defined in both the event and the shared pools, the shared variable is what's going to be resolved. Now we can use variables in pretty much all of the fields in the rules processor. We can use a variable for the job name or for our alert keys or text. We can also We can also compare our variables to see if they qualify an event for processing in the rules processor. And that's done in the SV screen. We can also update variables as an action to an event, and we do that in the action variable screen or AV display. AutoOperator also has support for sysplex variables, and sysplex variables are used to pass data amongst the sysplex between AutoOperators. This is done via the BBPAR member AAO-PRM, and you need to set a value SPLX vars equal to yes. Then there are a couple other parameters that are optional if you wish to change the names of the variables. Now the variables can be assigned values only using rules or execs. You cannot use the BBI var because the BBI var is allocated to a particular BBISS, and these sysplex variables get stored in the coupling facility, so they're shared, and we don't want to reload them for all these different BBISSs. AutoOperator also provides profile variables that are maintained in their own variable pool. You'll have one profile pool for each BBISS, and these variables are stored in the extended private area of the BBISS. The profile variables are only accessible from execs. You cannot use them from rules, and they do endure across IPLs and cold starts as they're hardened to disk. So when do these get hardened to disk? When an exec ends, the profile variables are updated on disk, or when you issue the IMF exec v checkpoint function. Now you can access exec variables by using the IMF exec vput and vget functions. You can also display them with the .v_v. You should consider, especially if your execs are using the same variables, to use the variable enqueue and the variable dequeue functions so that you don't step on yourself. AutoOperator supports the substring in a variable to return a portion of the variable instead of having the whole thing. The way this is structured is we basically say the name of the variable, colon, which column you want to start in or which character you want to start at, colon, and then the length of data that you want to retrieve. So in this case, we have IMF text, colon, 11. That says, okay, AutoOperator, I want you to take the value of IMF text, and I want you to start in position 11 and give me the rest of it. And 11 happens to coincide with where message starts, so we get message. In the second example, we say IMF text, colon, 6, colon, 4, which is saying I want the data starting in column 6 for a length of 4, and that translates to is A. So you get the gist of it. It's pretty easy to use and it's very powerful, especially when you want to capture something out of part of a word of a message, and then you want to translate that into a command or another message you want to issue to the console. It's also possible to remove the leading and trailing blanks from your variable values. It's very similar to the rect strip function. And the way we do it is we just put a trailing slash at the end of our variable name, and that'll remove any trailing blanks. It's also possible to concatenate a variable with a fixed string of data, and the way we would do it in this case is we have ampersand word1, which is the variable, dot sysa, which is the text, and that'll resolve to the value of word1 and then sysa. The period is removed because it denotes the end of the variable name. Now, variables can be ended with a whole bunch of different characters. They're listed here. I'm not going to read through them, but generally any of the special characters you would use, but we strongly recommend that you use a period for ease of readability. In the rules processor, we can also set variables, and they're really easy to do. On the AV screen, we specify the variable name on the left, and then on the right, we specify the value that we want to specify for the variable. Now, you can increment and decrement on this panel as well by putting a +1 or a -1, which can be handy if you're using counts to spawn additional automation based on the setting of these values. This concludes MVAO 201.